Hello, today I'm going to talk about sharing data science artifacts across teams using Crane. I'm Lucianos, I work at Open Analytics, a data science company based in Antwerp, Belgium, and we focus on methodology consulting, scientific programming, application development and integration, and deploying data science platforms. Crane is an open source application we developed using the Spring Boot framework, which we want to use for sharing data science artifacts with specific users, for example, your data science team, company users like the HR or other departments or teams, or even with the open public, namely the rest of the world, or unauthenticated users we don't know about. To do this, we needed to implement some requirements or features, namely authentication, which we did using OpenID providers, authorization, which is defined in the configuration file of Crane, and lastly, we want to allow users to create, read, update, and delete data science artifacts, which, to be frank, are just files, PDF files, R Markdown files, HTML files. It doesn't really matter. It's just a fancy word for files. Crane, on a high level, connects the users with a storage location, and when authorization rules are defined in the Crane configuration, well, it also uses an OpenID provider to identify the users and then determine whether these users have access or are allowed to see the files they are requesting to see. To use Crane, you need three things. You need Java 17 or later. You optionally need an OpenID Connect server, as I said, only if you're using the authorization rules of Crane. And lastly, you need a configuration file. This is what we're going to focus on the next slides. The configuration file is in the YAML format and has two root properties. The app property, which we are going to focus on, which contains Crane specific configurations, and the Spring property, which contains configurations related to Spring Boot applications in general. One of the configuration options, for example, that Crane would need is the storage location property, which defines where Crane can find the files it needs to share with the users. If you want to connect Crane with an OpenID server, you can use, for example, the OpenID issuer URI to define where it can find the OpenID server. And you can also define, for example, the OpenID groups claim to define where the groups or which claim contain the groups for a user. In this case, we define this claim to be named as groups. For another property that's more security related is called audit logging property, which defines a file location where Crane will dump user actions to, for example, have a better look at possible disaster scenarios, like why did a very confidential file get deleted and by whom. Then the last property in this example is the repositories property, which is the property we're going to focus on next. This property contains the folders or directories which we want to share with our users. The first level of these folders is called repositories, as the property name suggests, and all the subdirectories inside repositories or even subdirectories of subdirectories are called paths. So the configuration tries to follow a tree structure which is typical for files. And in this case, we define for all the folders that are found in this storage location, namely the data scientist folder, public folder, internal folder, DevOps, FinOps, HR, mathematicians folders. For some of these repositories, we also define the subfolders using the paths property, namely Team 1, Team 2, Team 3, and Team 4 subfolders for data scientist repository. But note that defining these paths is optional and should only be used if you need specific configurations for these paths or subdirectories. For example, in the public repository, we also have a subfolder, but this one is omitted as everything in the public repository in our example just needs to remain public and should be accessible by all users. So now, how would we define this accessibility? Well, this is done using the access control configuration provided by Crane. There are two types of access control, namely read and write access control in Crane, and these can be configured using the read access and write access properties. We're going to focus on the read access property, as all the subproperties of these two access control types are exactly the same and work in the same way. So in the example we are going to discuss, 3 repositories are defined: the data scientist repository, the public repository, and the internal repository. In the data scientist repository, we define read access using the groups property, which contains a list of groups which, if your user is part of any of these groups, will get access to the contents of the data scientist's repository. In this example, the groups are team 1, team 2, team 3, or team 4. In case we want to restrict the access of a specific subfolder, we can then use the paths property to define a subfolder, in this case team 1, the team 1 subfolder, which, as the name suggests, we would only like to give access to members of team 1. So then we use the groups property to define that only users in the team 1 group should have access. But for some reason, this company has a user Sam, which also should have access to the team 1 subpath. And this we can define using the users property, which takes a list of usernames. We could further allow access to other users, for example, using the network property, which will define a specific IP address from which users do have access to the team 1 folder, or even defining complex expressions using the expression property, which accepts SpEL expressions to define more complex rules. Then the public repository, as I stated before, should be public, so it should be accessible for authenticated and unauthenticated users. To do this, we would use the public property and setting it to true, and that would achieve the goal we have. So all the contents of the public repository are now accessible to any authenticated and unauthenticated user that is able to reach our Crane deployment. If we want to have for the internal repository, we defined the any authenticated user property to true, which, as the name suggests, gives access to any authenticated user. To make this a bit more concrete, I would like to give an example using the user Sam, which is part of 3 groups: Team 3, DevOps, and the Mathematicians groups. Sam tries to access a file inside the Team 1 subfolder, which is a subfolder of the data scientist's repository. So Crane, to determine whether Sam has access to this file in Team 1, Crane will check the access control rules of the data scientist repository first. Namely, well, Sam will get access as he is part of one of the groups inside the read access groups property, namely Team 3. Then Crane will check the Team 1 subpath rules, and there Sam will get access not because of the groups property, because she's not in the Team 1 property, but because of the users property, as he is part of one of the users defined there, namely Sam. And thus, Crane will then give him access to the file or subfolder inside the Team 1 path. To showcase how Crane looks and the UI of Crane, first I'm going to show an example of an unauthenticated user. As you can see, there is a login button at the top right, and then a list of repositories. In this case, only one repository, namely public. The user clicks on this. He sees a list of files inside the public repository and clicks on the crane.html file. This file opens an HTML page, namely containing the Crane documentation site, and the user just browses through that file and then goes back to the Crane site. The next example will use the SAM user. He logs in using the login button. He's redirected to the KeyCloak instance in this case and logs in. He sees more repositories and clicks on the data scientist repository and then goes forth into the team3 path and clicks on one of the data files there. This is downloaded and opened in a text editor. Then he goes ahead and goes to the home page of Crane, clicks on the public repository where he sees a upload button. He clicks on the upload button, uploads a file, and this file is the application.yaml used for the Crane configuration. After uploading the file, he clicks on the file and then goes ahead to select the rule that gave him write access to the public repository, namely using the user's property and passing the list containing the user SAM. Not only can you use the UI of Crane, but you can also use API. In this case, I'm going to showcase this using the R package HTTR2. We create a response to a specific path in the Crane deployment. In this case, the root of the Crane deployment. We need to add an authorization bearer token to the headers, so we use the request headers function to do this and perform the request. The response of the request is a JSON, so we use the response body JSON function to parse this, and the result is a status, an object with a status property and a data property containing the status property containing the status of the request, and the data property containing directories, a list of directories, and a list of files. You can also upload files using the API, so you can you need to create a request to the path you want to upload the file to with the file name at the end. So in this example, /public/data.csv. You need to change the method to a post method as you want to do a post request. Add the authorization header again with a bearer token. Add a multi-part body containing the contents of the file and the file name, and then perform the request. This again is going to result in a response with the JSON format, so we use the response body JSON function to parse this, and we get an object containing some information about how the upload was performed or not performed. Crane also has a lot of other features which I'm not able to talk into or explain in detail, so I wanted to just have a fast overview of them, or just briefly touch on them. You can define alternative behavior on errors, which means, for example, if you had a 404 because the file you wanted to find was not in a specific repository, you could define in this repository to redirect the user to another site. So it would use the file, the whole path of the file or you are searching for, and then use it on another site. And this could be used, for example, to install packages, internal packages using Crane as a package storage. And then if a package, for example, NumPy is not in your Crane deployment, then you can redirect users to PyPy. In the example I showed, local storage was used, but we also support S3. If you are in a high security setting, you can use POSIX access control on top of the access control in the configuration. The UI I showed is fully customizable, and it's just a template that's provided with the Crane, the standard Crane UI. You can define repository-specific storage locations. Auditing, as I already mentioned, is possible in Crane, which will just log all the actions taken by users. And you can also configure Crane to only serve public files, and thus dropping the OpenID Connect server requirement. There are much more features which you can have a look at Crane.net, craneserver.net, documentation website of Crane. And if you want to know more about Open Analytics, just surf to openanalytics.eu or use one of the QR codes in these slides. Thank you very much for your attention and have a nice day.